Welcome to the Agentic AI series, where we build one agent piece by piece across its whole architecture. In this demo, we cover protocols and interoperability. Back in Demo 3, we handed the agent tools directly, baked into our own code. That doesn't scale. MCP, the Model Context Protocol, is the standard way to serve those same tools over a clean interface, so any agent that speaks the protocol can pick them up without us rewiring anything. This is the first half of interoperability. The agent stops being a closed box and starts plugging into a shared ecosystem of tools it didn't have to own. This is the MCP demo, the Model Context Protocol. We will cover 4 frameworks: OpenAI, LangGraph, CrewAI, and Microsoft. In each one, the agent reaches for its tools over a shared protocol, instead of carrying those tools inside its own code. In the previous demo, we took one tool and we wired it into 4 different frameworks, and in this demo we will take that exact same tool and move it out to a server. The tool you already met is about to leave the project and live somewhere any agent can reach it. So what is MCP? The Model Context Protocol is an open standard for serving capabilities to agents, tools, data, and more over one shared interface. In this demo, we focus on tools. You run them once, in one place, and any agent that implements the protocol can use them. The agent does not need to own the code, and it does not need to know how the tool works. Think of it as a power socket for tools. The server provides the socket, the agent plugs in, and the two of them agree on the shape of the plug. That shared shape is the protocol. Nothing else has to match. Here is the problem it solves. In the tools demo, the logic lived inside our project as one shared function that every framework called. That works, but it does not scale. If 5 projects need the same tool, you are wiring that tool into 5 places, and you are maintaining it in 5 places. MCP breaks the knot. You lift the tool out of the project and you put it behind a server. Now there is one copy to run, one copy to fix, and one copy to secure. Every agent connects to the same server, and the tool itself never moves again. This is the server. We build it with FastMCP, and we expose 4 tools on it. There is getSchema, which returns the database layout. There is validateSQL, which checks the syntax. There is validateSQL names, which checks the tables and columns against the schema. And there is queryEmployees, which runs the query and returns the rows. Notice the decorator. Each function is marked with an mcp.tool, and that single line is what publishes it to the protocol. The body is the same code from the tools demo. We did not rewrite the tool. We simply gave it a doorway to the outside. And this is how an agent connects. The client opens a standard input-output channel to the server, it starts a session, and it calls initialize once to shake hands. From that point on, the agent does not import the tool at all. It calls it by name. The key line is call tool. The agent says call tool, query employees, and passes the query, and the server runs it and hands back the result. The same 4 steps work for every framework. Open the channel, start the session, ask for the schema, then call the tool by name. If you're enjoying this, please like and subscribe so the next video finds you. Now let's keep going. OpenAI. The agent describes one function to the model, queryEmployees, with a small schema for its input. When the model decides to call it, OpenAI hands you the call, and you forward it straight to the server with call tool. The model chooses the query. The server runs it. Your code is just the wire in between. LangGraph. Here the connection lives a little longer. The client holds the session open in the background and keeps it ready, so the agent can reach the server on every step of the graph. When the agent calls query employees, that call is routed through the same session to the same server. The graph does the thinking, and the session does the reaching. Crew AI. Crew AI tools are plain functions, so we wrap the server call in one. We write a function called query employees, we decorate it with that tool, and inside it we call the server with call tool. The crew sees an ordinary tool, and it never learns that the real work is happening in another process. That is the whole point. The framework does not have to know. Microsoft Agent Framework. The pattern is the same one more time. We define query employees, we mark it with add-I function so the agent can see it, and the body forwards the call to the server. We hand that tool to the chat agent, and the agent calls it whenever it needs data. For frameworks now, and the same two moves every time. Wrap the server call, and hand it over. So that is MCP. For frameworks, one server, and one tool that none of them owns. The agent could now plug into a shared ecosystem of tools it did not have to build. This was the first half of interoperability, agents talking to tools. There is one piece left. In the next demo, the agents stop talking only to tools, and they start talking to each other. That is A2A.
Thank you for spending time with us. Like and subscribe. Stay sharp, stay Azurite. See you in the next one.